In modern system design, the front door of your architecture is its most critical point. When a request leaves a user's device, it travels across the public internet and eventually hits a boundary. This boundary is responsible for making sure that request finds its way to the right piece of code. Historically, we've relied on load balancers to handle this. They act as traffic cops, ensuring no single server gets overwhelmed by balancing the load across a fleet. But as we shifted toward microservices, the needs of this front door changed. We started needing to verify user identities, transform data on the fly, and manage complex routing rules that simple traffic distribution couldn't handle. This led to the rise of the API gateway. While they might look similar on a high-level diagram, their internal logic and primary goals are fundamentally different. Today, we'll explore exactly where one ends and the other begins.
Let's start with the load balancer. Its primary mission is availability and efficiency. Think of it as a pure distribution engine. It usually operates at layer 4 of the OSI model, dealing with IP addresses and ports, or layer 7, where it can see HTTP headers. When a request arrives, the load balancer checks the health of the downstream servers. If server A is busy or down, it redirects the traffic to server B or C. It uses simple algorithms like round robin or least connections. It doesn't care about what's inside the API request. It only cares about the network health and ensuring that no single server becomes a bottleneck. It's built for high throughput, low latency packet forwarding. In short, it is a horizontal scaling tool.
An API gateway, however, is much more intelligent. It is an application-level component that acts as a reverse proxy, but with a heavy focus on business logic and security. While a load balancer just passes traffic through, a gateway intercepts it. It performs authentication, checking if the user's JWT is valid before the request even hits your microservices. It handles rate limiting, ensuring a single user doesn't spam your API. It can even perform protocol translation, taking a REST request from a mobile app and turning it into a gRPC call for your internal services. It provides a single, unified entry point for a complex web of services, often handling cross-cutting concerns so your developers don't have to write the same auth code in every single service.
To visualize the difference, look at where they sit in the OSI model. A load balancer is typically lower, operating at layer 4, TCP, UDP, or layer 7, HTTP. Because it has less work to do per packet, it is incredibly fast. An API gateway is firmly at layer 7 and above. It needs to parse the entire request body to make decisions. This makes it heavier and slightly slower than a pure load balancer, but far more capable. A load balancer asks, which server is free? An API gateway asks, who is this user? Are they allowed to see this data? And how should I form out the response for them? One is about transport, the other is about semantics.
In a real-world architecture, you don't usually choose one over the other. You use both in a chain. First, a layer 4 load balancer receives the massive volume of raw traffic from the internet. Its job is to distribute that load across a cluster of API gateways. This ensures that the gateway itself can scale horizontally. Once the request hits the API gateway, the heavy lifting of authentication and routing happens. The gateway then sends the validated request to the specific microservice that needs to handle it. Think of the load balancer as the security gate at the front of a stadium, and the API gateway as the ticket collector and usher who tells you exactly which seat to sit in. They work in tandem to provide both scale and control. If your requirement is health checking, SSL termination, and simple TCP balancing, you need a load balancer. If your requirement is API versioning, complex routing based on JSON payloads, API key management, or request retries based on business logic, you need an API gateway. Cloud providers often blur these lines. AWS Application Load Balancer can do some basic path-based routing, and tools like Kong or Nginx can act as both. However, keeping these concepts separate in your mind will help you design more maintainable systems. Don't overload your load balancer with business logic, and don't expect your gateway to handle layer 4 packet distribution at massive scale. Ultimately, the choice depends on your scale. For a small monolith, a load balancer is likely all you need. As you grow into a microservice mesh, the API gateway becomes the essential glue that protects your services and provides a consistent experience for your API consumers. Choose the right tool for the job, and remember, infrastructure is about making the complex feel simple. Thanks for watching this deep dive into system architecture.